Hey everyone, welcome to Sequence of Instructions. Thanks for joining me. In this video, we're going to be learning a sorting algorithm called bubble sort. This one is probably one of the first sorting languages they'll teach you in school. It's pretty simple to implement, but it's not very fast. So normally you'll use it when you're just trying to prove that a function works, and then once you've proved it works, you might use a different sorting algorithm. I mean, in most cases, you don't even need to implement sorting algorithms because there's tons of libraries out there with them already implemented, but it's nice to know, and sometimes you'll use variations of it in your projects. And then obviously once you've proved that your function works, you might refactor to use a more performant sorting algorithm. Basically the way it works is you'll have some array of data. I'm just going to type some numbers in here. Randomly, got 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. So here's some unsorted array that we're going to want to sort. The way bubble sort works is it's going to basically compare every element to every other element. So this 9 is going to be compared to 8, 4, 5, 6, 7, blah, blah. Then we compare the 8 to 4, 5, 6, 7, 1, 2. So every number is going to be compared to every element that comes after it. And the idea is when you're comparing two, if the one on the left is larger than the one on the right, you're going to just swap their spots. So I'm going to pull this 9 out, I'm going to pull the 8 out, replace it with a 9, then replace the original 9 with an 8. Right, and so if you keep doing that, you'll see that each number is going to sort of bubble its way to its final location. The larger numbers are going to bubble towards the top, the smaller numbers are going to bubble towards the bottom, and hence how it gets its name bubble. You can kind of imagine like sand shifting into place. So the actual implementation is pretty straightforward. I'm going to make a function to do it, where we're going to get some array of data, and we're going to implement bubble sort to replace it in line. So the way it works is you're going to have an outer loop, I equals 0, starting at 0, and going to the length of the array. You're then going to have an inner loop, which is going to be exactly the same or very similar, going to the length again. Now, right off the bat, I can tell you a few things. We're never going to compare this first number to itself, and you might have heard me say before, this will require a little more proof, but you're not going to need to compare numbers that you've already passed. So you can actually start this inner counter at I, and because we're always this inner counter is kind of a look ahead, so 8 compares to 4, 5, 9, when we get to the 9 for I, when I equals this position for 9, we're going to compare it to 6, 7, 1, 3, 2. We're not going to really be looking back. So because it's sort of this look ahead, you also don't need this outer counter to go to the last element. Because the last element's not going to have anything to compare to ahead. So you can actually stop at -1, which also means we can start j at I plus 1. So again, when I is at this position index 1, we don't want to start j at 1 because they're always going to be equal. It's not going to do anything. We want to start to the next one. It's always going to be a look ahead. All right? So this is the most efficient version of bubble sort. And again, it's not very efficient, but this is as close as it comes. And now, like I said before, the logic's pretty simple. We're going to just check, is position I greater than position j? And if it is, if they're equal, so the reason we don't have to greater than or equal to is because if they're equal, we don't really care. We don't swap them. They don't change at all. It wouldn't do anything to swap them. But if it's greater than, what we're going to do is we're going to store data of j, right? Because we're going to be overwriting it. So we need to remember what the original value was. So we store data of j. We set data of j's value to whatever is at data of I. And then we put data of I back to what we had stored in temp. So again, let's say we're at this 9 and this 6. The I points to 9, the j points to 6. We're going to go, all right, pull this 6 out. So temp is going to be 6. Make this 6 a 9. Make this 9 whatever temp was, which is a 6. And then we don't care about temp. So you'll see that they will have switched spots. All right, that is all there is to it for bubble sort. Just to prove to you that this works, we'll log our array. Then we'll bubble sort our array. And then we'll log our array again. Let's check it out. Hopefully this works. There it is. Oops. Sorry about that. So our first array unsorted, we called bubble sort on it. It sorts at 1, 2, 3, 4, 5, 6, 7, 8, 9. Beautiful. It seemed really fast, and it is because our array is only, 9 characters long, 9 elements long. But if you had 100, 1,000, 10,000 lengthed arrays, it builds really quick because you're comparing every element to every other element. The number of times it has to go through this checking process is the length of your array squared. So 9 squared is only 81. That's not a big deal for computers. 81 checks is not bad. But if you had 10,000 elements in your array, 10,000 squared becomes a much larger number, and the computer can actually choke on that. So, but anyway, that's why bubble sort's not super efficient, but also pretty easy to implement. Doesn't take a lot of brain power to think about it. You can kind of, once you've done it a few times, you can just write it from memory really quick. Anyway, thanks for watching this video. If you have any questions, leave them in the comments. Until next time, take care. Bye.